Okay, so part 2 of the video, we're going to do some examples of how to use that long derivation that we did, that formula we came up with, to actually find some Taylor series. Okay, I'm going to start with an example from section 3 to find the third degree Maclaurin polynomial for f of x equals e to the x. Okay, now if I want a third degree polynomial, I only need to get up to an x to the third power, and that's going to only require up to a third derivative, because if you remember the formula, the third derivative was attached to the x cubed term. So all I need to do is find up through my third derivative. Okay, so I usually make a chart, and please excuse me, I'm just going for ugly handwriting right here. Okay, so I make a chart with f of x, f prime, f double prime, f triple prime until I have what I need. And then I also know that I'm going to need to be plugging my center into these, my function, my derivative, my second derivative, my third derivative. Now, if I ask for a Maclaurin polynomial, where is that polynomial centered? It's centered at x equals 0. So I'm also going to need f of 0, f prime of 0, f double prime of 0, f triple prime of 0. So go ahead and pause. My function is e to the x. Go ahead and find all these pieces of information for all these. Okay, so with f of x being e to the x, then f prime will also be e to the x, and then the second derivative will be e to the x, and my third derivative happens to also be e to the x, okay? And then if I'm going to plug 0 into all these, okay, if I plug in 0 for x in all of these, I'll have e to the 0, which is 1 for each of them. Okay, so now I'm going to put that together with my formula for Maclaurin polynomial. Okay, and the general form that I derived from the first part of the lesson is that my Maclaurin's series, okay, I shouldn't have a plus dot dot here because I'm asking for a third degree polynomial. So I just amended this to f of x as approximately f of 0 plus f prime of 0 over 1 factorial times x to the first plus f double prime of 0 over 2 factorial x squared plus the third derivative evaluated at 0 over 3 factorial x cubed. And if I plug in, my third degree polynomial would be p sub 3 would be 1 plus x squared over 2 factorial plus x cubed over 3 factorial when everything is put in and simplified. Okay, right, because each of my f of 0, f prime of 0, f double prime of 0, f triple prime of 0 just are 1. So that's that. Okay, so that's the third degree Maclaurin polynomial for f of x equals b to the x using the formula that I derived in the last video. And you can see that it's a really, really easy, friendly process, especially when you make a table the way that I did. Okay, so for the next problem, I just want to highlight the difference between a Maclaurin polynomial and a Maclaurin series, okay, because we might as well talk about both. A Maclaurin polynomial, we're going to stop at whatever degree they're asking for, we stop at that derivative. So last one, they asked for a third degree, we stopped at the third derivative. If they asked for a fourth degree, we would have stopped at fourth derivative. Second degree, we would have stopped at second derivative. If I'm asking for a series, you need to keep going with that chart or that table that we were making until you notice a pattern. Okay, so with e to the x, it's real quick and easy to see a pattern, but if it was a more complicated function, then I would just keep going until I recognized a pattern. So go ahead and make your chart, f of x, f prime of x, f double prime of x, and so on, and then plug in your center. Now it's a Maclaurin series, so where is that series centered? It's centered at 0. Maclaurin means centered at 0. So I'm going to do f of 0, f prime of 0, f double prime of 0, and so on. It's the same information from last time, but let's do it anyway. So pause, do your chart, come back to me. Okay, so here's my chart not filled in, and then I'm going to go ahead and fill it in, and I just added a line at the end just to generalize for the nth derivative and the nth derivative value at 0, but it's going to look exactly like it was in the last problem. Okay, so my derivative, no matter what what derivative I take for e to the x is just e to the x, including the nth derivative is also e to the x, and then if I plug in 0 to any of those, I have e to the 0, or 1, for all of them. Okay, so now when I generalize from the Maclaurin series, it's going to look a lot like my Maclaurin polynomial from the last one, except my main difference is going to have a plus dot 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 at the end. Okay, so here's my general form. Oh, you know what? I don't want this one. I want this one. I have f of x as just f of 0 plus f prime of 0 over 1 factorial x to the first plus f double prime of 0 over 2 factorial x squared, and so on. And the important thing is that plus dot dot dot, and this will look like this. Okay, so again, I just want to highlight the big difference between finding a Maclaurin series and a Maclaurin polynomial. As a Maclaurin polynomial, you only care to get up to the derivative that you've been asked for that degree. So second degree, second derivative, fifth degree, fifth derivative, eighth degree, eighth derivative. If you're asked for a series, you need to keep going until you recognize a pattern. And it would have been real quick and easy on this one. I probably wouldn't have had to take as many derivatives as I did. Also, when you're writing it, in the last one I either wrote p sub 3 equals or that f of x was approximated by. Here I write f of x equals, and there's got to be a plus dot 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 at the end. Okay, let's do another. Okay, so something really important happens when I change the center of my series, okay? If I change the center of my series, that means that, first of all, my entire problem has to have x minus 2's in it to be centered at a equals 2, because, again, I'm centered with whatever's being subtracted from my x when it's being brought to the power, or whatever number I can plug in that makes every term but the first go out to 0. So if I'm going to be centered at 2, my general form would look like this. I'd have f of 2 plus f prime of 2 over 1 factorial times x minus 2 to the first plus f double prime of 2 over 2 factorial times x minus 2 squared, plus the next term would be f triple prime of 2 over 3 factorial times x minus 2 cubed, and so on. Okay, so again, I need to do this up until I find a pattern, and it's quick and easy to see what that pattern would be, but I'm going to start by making my chart. Okay, so I'm going to need f of x, f prime of x, f double prime of x, and so on. And I know e to the x, that's going to be easy to see a pattern, so I'm not going to go very far with this. Okay, so I have f prime, f double prime, and now I need to plug in, now I'm centered at 2. I need to not plug in 0 this time, I need to plug in 2. Okay, so that would look like this. Okay, so here's my general chart. I'm not going to go further than this just because I know that function e to the x is going to be real easy to see a pattern, but otherwise I would keep going until I saw a pattern. And go ahead and fill in the information in your chart, pause, and come back to me. Okay, so my value of my function, my derivative, and my second derivative, all at 2 are e squared, and I can see that the derivative is always going to be e to the x, so the derivative evaluated at 2 is always going to be e squared. And now if I plug in to my general form up here, okay, if I plug into this general form, I'm going to have the following. Well, you plug in, you pause it, you come back to me, and then if you plug in all those e squareds in for f of 2, f prime of 2, and so on, you have this. Okay, and you don't need to have the 1 factorial in there, but there's no harm in having it. But I would have e squared plus e squared over 1 factorial, x minus 2 to the first, plus e squared over 2 factorial times x minus 2 squared. My next term would be e squared over 3 factorial times x minus 2 cubed. My general term is e squared over n factorial times x minus 2 to the n. And notice I have f of x equals, I have a plus dot 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 at the end because I asked for a Taylor series. Okay, what I would like for you to do now is I would like for you to pause the video, and on your calculator I would like you to graph e to the x, and then in like y1, and then in y sub 2, I would like for you to graph some of the terms of this series, and it's kind of a pain in the butt to input, but if you factor out the e squared, it'll be a little bit easier, and maybe enter 3 or 4 or 5 terms of the series, and see what the difference in the center is, or what difference the center makes. And we're going to discuss this in class tomorrow. Okay, let's look at another one. Okay, and one of the things that I discussed in class already is that the nth degree polynomial has highest degree n. It does not necessarily have n terms. Okay, so actually here's a real easy one. I want the 4th degree Taylor polynomial for f of x equals e to the x squared centered at 0. And what I failed to mention previously is that this Taylor series for f of x equals e to the x is our 4th big series that you need to have memorized for the AP exam. Okay, so you need to know that e to the x is the series that we came up with. Okay, 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. The general way to write this is the sum from n equals 0 to infinity of x to the n over n factorial. Okay, and one of the things that I would like for you to do at some point, either pause now or do it after, is graph e to the x and graph some of the terms of this series and tell me how long you think they will hug each other for. Okay, is it a finite amount? Like, is it a little hug, like that geometric one was for 1 over 1 minus x? Or is it an infinite hug, like it was for sine and for cosine? So think about that, okay? But in any case, what I can do, knowing this series for e to the x, and knowing what we did from section 2, where we were able to do composite functions, as long as I'm centered in the same spot, okay, and here I'm centered at 0, and this series for e to the x is also centered at 0. One of the ways you could tell is that I only have x to the nth power. It's x minus 0 to the nth. Okay, I can just do a simple substitution. So if I want e to the x squared, I can do like a composite. I can replace every x with an x squared. Okay, so thinking about what we did in section 2, I would like for you to try to pause the video and try to make the substitution, replace all your x's with x squareds, pause, and come back to me. Okay, and if I make the substitution, I'll have 1 plus x squared squared over 2 factorial plus x squared cubed over 3 factorial, and so on up to x squared to the n over n factorial, and so on. And I'm just going to go ahead and simplify this one. So pause, simplify it, come back to me, and you should have this lovely series, 1 plus x squared plus x to the 4th over 2 factorial plus x to the 6th over 3 factorial, and so on. The general term would be an x to the 2n over n factorial. And again, just notice I have an equal sign, so I'm going to have my plus dot 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 at the end. Okay? All right. Oh, you know what? They asked me for a 4th degree. I asked you. I'm sorry. Nobody asked me. I asked you for a 4th degree Taylor polynomial. So I was just on autopilot finding a Taylor series. What would the 4th degree polynomial be? Write that out for me, please. Pause and come back to me. Okay, and a 4th degree polynomial would end with my highest power of x to the 4th. So this would be my 4th degree polynomial, okay? 1 plus x squared plus x to the 4th over 2 factorial. And notice what I was trying to say earlier. I have 3 terms to my 4th degree polynomial, okay? So 4th degree does not mean 4 terms. It means ends in an x to the 4th. And notice I wrote p sub 4 equals. If I didn't want to write p sub 4 equals, I could also write e to the x is approximated by, and then I would just repeat this, 1 plus x squared plus x to the 4th over 2 factorial. Okay, one last example for you guys. I want a 3rd degree Taylor polynomial for f of x equals square root x centered at 1. Okay, so again, if you're asked, now I don't have any basis for this. It's not looking like a geometric, or it's not like e to the x or sine x or cosine x, which are the ones that I need to know. So I'm going to just go ahead and make a chart. So I need a function, a first derivative, a second derivative. How many derivatives do I need? Well, you're asked for a 3rd degree, so you're going to go up to a 3rd derivative. So make your chart, pause, come back. Okay, so function, first derivative, second derivative, 3rd derivative, I stop at 3rd derivative because it's asked for 3rd degree. And now my center is at 1, so what am I plugging into my function, my first derivative, my second derivative, my 3rd derivative? Plugging in 1, so the rest of the chart looks like this. Okay, so I have f of 1, f prime of 1, f double prime of 1, f triple prime of 1. So go ahead and figure out what those things are. And I think I'm just going to go for some sloppy handwriting here. So go ahead and pause and come back to me. All right, my function is square root x, okay, or x to the 1/2. Its derivative will be 1 over 2 square root x, okay, or 1/2 x to the negative 1/2. When I take that derivative, I'm going to get a negative 1/4 x to the negative 3/2, or negative 1 over 4 x to the 3/2. Okay, that's negative 1/4 x to the negative 3/2, and if I take that derivative, I will have 3 over 8x to the 5/2. Pardon my sloppy handwriting. Okay, now once I have my derivatives, and hopefully I didn't make any mistakes there, I'm going to plug 1 into each of them. So for the f of 1, and again, if you're not there yet, pause, do it, come back to me. F of 1 is going to be square root of 1, or 1. Okay, f prime of 1 will be 1 over 2 square root of 1, or 1/2. F double prime of 1 will be negative 1 over 4 times 1 to the 3/2, which is negative 1/4. Okay, and then f triple prime of 1 will be 3 over 8 times 1 to the 5/2, or 3/8. Okay, now I'm going to use my general form for a Taylor polynomial centered at 1. Now I just want a 3rd degree, so my 3rd degree polynomial would look like this. I should say pause, write out what that general form would be, and come back to me, and it'll look like this. F of 1 plus f prime of 1 over 1 factorial x minus 1 to the 1st plus f double prime of 1 over 2 factorial times x minus 1 squared plus f triple prime of 1 over 3 factorial times x minus 1 cubed. Okay, and if I go ahead and plug in these values up here, okay, I will have, well, you do it, pause, come back to me. Okay, so I put in all my coefficients and I got this loveliness. And I would like for you to again pause, simplify, and come back to me. And you should have this for your 3rd degree polynomial. All right, so I'm racing the clock here, but I'm done with our examples. The last thing I have is a recap of those 4 really important series that you need to know for the AP exam. Notice that I have a finite number of terms, so I just have an approximation here, okay? So that is that.